Hello everyone, myself Disha Lal, Assistant Professor in Civil Engineering Department working at Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Subject is Basic of Civil Engineering and the topic is Introduction to Surveying. The content covered in this chapter are Introduction, Fundamental Principles of Surveying, Classification of Surveying, Application of Surveying, Plans and Map, and Scale. Surveying is one of the basic area in civil engineering which includes linear and angular measurement of the relative position of the point on the surface of the earth. After taking the measurements in the field, computations are done and plans and maps are prepared in the office. These plans and maps are used for planning of engineering works, marking of boundaries, computation of area and volume. Objects of surveying: to take a measurements to determine the relative position of the point on, above or beneath the surface of the earth, to determine area and volumes, to mark the position of the proposed structure on the ground, for example buildings, canal, road, etc., to prepare a map or a plan to show the relative position of the objects on the surface of the earth, to fix the boundaries of a districts, states and countries. Fundamental principles of surveying. Basically, there are two fundamental principles of surveying. First, to work from whole to the bar. In this, the entire area to be surveyed is first considered, that is A, B and C. Then its smaller parts are considered, that is P, Q and R. So this principle states that it is essential to first establish a control points with high precision and they are further subdivided into smaller area with slightly less precision. The object of this system is to prevent the accumulation of error. The control points are A, B, C, right? The minor control points are P, Q, R and X, Y, Z. ABC, that is the main framework, and XYZ, that is the subsidiary framework. Second principle is to fix a position of a new point by at least two independent processes. The fixation of a new point in relation to the point already located can be done by either linear measurement or angular measurement, or both linear and angular measurement. In linear measurement we have to measure a distance, and in angular measurement we have to measure a angle. For example, locating a point R, take a Q point as a reference point. In first figure, figure number A, measure a distance PR and QR. In figure B, for establish a point R, QSR, that is a right angle, and measure a distance QS and SP. In figure C, for locating a point R, angle PQR and distance QR are measured. In figure D, for locating a point R, angle PQR and angle QPR are measured. In figure E, for locating a point R, angle PQR and distance PR are measured. Classification of surveying. Surveying is classified into two types: primary division of survey, secondary classification of surveying. Primary division of surveying is further subdivided into two types: plain surveying and geodetic surveying. Secondary classification of surveying further subdivided into four types based upon the nature of the field survey, based on the purpose of survey, based on instrument used, and based on method employed. Plane and geodetic survey. In plane surveying, the mean surface of the earth is considered as a plane. So all the lines are considered as a straight line and the triangle is considered as a plane triangle. And in geodetic survey, the surface is considered as a curved surface. So the all lines are considered as a curved lines and the triangle is considered as a spherical triangle. So in plane surveying, the spheroidal shape is neglected. Difference between plane survey and geodetic survey. Plane survey is the type of surveying in which the mean surface of the earth is considered as a plane and the spheroidal shape is neglected. In geodetic survey, it is the type of surveying in which the spherical shape of the earth is taken into account. Plane survey, all survey lines are considered as a straight and all triangles are considered as a plane triangles. In geodetic survey, all survey lines are considered curved and all the triangles are considered as a spherical triangles. Plane survey is used for the survey of small area. Geodetic survey is used for the survey of large area. In plane survey, the standard accuracy is low and in geodetic survey, the standard of accuracy is high. In plane survey, the direction of plumb line at various points are assumed to be parallel to one another. In geodetic survey, the direction of plumb line at various points are not parallel to one another. Plane survey is useful for engineering, architectural, commercial, scientific, etc. purpose. And geodetic survey is useful to obtain accurate maps of wide areas and establish control point for all other survey. Secondary classification based upon the nature of field survey. It consists of a land surveying, marine survey and astronomical survey. In land surveying, topographical survey is used to determine the natural features of a country such as river, streams, lakes, woods, hills, etc. Cadastral survey are made for fixing of a property line, the calculation of land area or the transfer of land property from one owner to another. City surveying are made in connection with construction of streets, water supply system, etc. Marine survey is deal with bodies of water for the purpose of navigation, water supply, etc. Astronomical survey is used to determine absolute location of any point or the absolute location and direction of any line on the surface of the earth. Secondary classification based on the purpose of survey. Archaeological survey conducted for unearthing relics of antiquity. Geotechnical and geographical surveys conducted for determining the different strata in the earth crust. Mine survey conducted for exploring mineral wealth and to guide mining operations. Military surveys conducted for military purpose. Control survey conducted for establishing a network of control points. Topographic surveys conducted to determine the nature of features of hill, river, lakes, towns, villages, buildings, road, railways, etc. Cadastral survey conducted to determine the details of boundaries of a field, house and other private and public properties. Route survey conducted to determine the alignment of highway, railway, canal, pipelines, transmission line, etc. Engineering survey conducted for collecting the data for engineering purpose like design of dam, road, bridges, etc. Construction survey conducted for location of construction work, giving line, fixing grades, etc. Secondary classification based on instrument used. First of all, chain survey. Chain or a tape is used for linear distance measurement. Compass survey. Compass is used for measurement of a horizontal angles. Plane table survey. Plane table is used for preparing plan of a given area and collecting the details. Theodolite survey. Theodolite is used for measuring vertical and horizontal angles. Tachyometry survey. Tachyometer is used for measuring horizontal and vertical distance. Photographic and aerial survey. Photographs taken from higher altitude are used for collecting the details of earth features. Electronic distance measurement survey. Device working on the principle of electronic distance measurement is used for determining the distance between two objects. Remote sensing. Data collection from satellite are used for determining the position and earth features. Secondary classification based on method employed. First of all, triangulation survey. The area is covered with a network of triangles and details are collected. In case of a traverse survey, the area is covered by a series of survey lines forming traverse and details are collected. Application of surveying to prepare a topographical map which shows natural features of a country such as rivers, streams, lakes, hills, valley, forests, etc. To prepare a cadastral map which shows the boundary of a field, plots, etc. To prepare a contour map to know the topography of the area, to find out the best possible site for a dam, canals, buildings, roads, railways, bridges, etc. Route surveys are conducted to fix the alignment of a road, railway, canal, electric tower line, tunnel, bridge, etc. on a ground. To plot a irregular boundary of a plot and existing structure on a paper. To lay particular gradient or a slope for water supply, drainage, gas line or a road. To carry out survey on lakes, rivers and sea to study the bed profile, finding out level difference between various points on the ground surface. Military survey is used for determining the points of strategic importance. Mine survey is used for the exploring mineral wealth. City survey is used for planning street, water supply systems, sewers, etc. Remote sensing is useful to determine agricultural soil, forest cover, water bodies, etc. Plan and map. Plan is the graphical representation of a building structure like a residential building, commercial building, public building, bridge, dam, etc. Architectural drawing for a building or a house, it is called as a plan. A plan is drawn on a small scale. That scale may be 1 centimeter is equal to 10 meter or less than 10 meter. If 10-meter length is measured on a ground, that can be represented as a 1 centimeter on a paper. On a plan, generally horizontal distance and directions are shown. A plan is drawn for a small area, for example, plan of a house, plan of a bridge, etc. Map. Map is the graphical representation of a bigger land like city land, land of a state and nation. We all know about the Google map that is used for the location of various area, that is called as a map. A map is drawn on a large scale. The scale may be 1 centimeter is equal to 100 meter or greater than 100 meter. If we are measuring a length of 100 meter on a ground, that can be represented as a 1 centimeter on a paper. On a topographic map, vertical distance are also shown by contour lines. A map is drawn for a large area, for example, map of Gujarat, map of India, map of Baroda, etc. Scale. The distance measured on a ground are plotted on a paper in such a way that the fixed ratio is maintained between the distance on a ground to the corresponding distance on a paper, so that scale is the ratio of distance on a map to the distance on a ground. If the scale of map is 1 centimeter is equal to 10 meter, it means that 1 centimeter on paper represent 10 meter on a ground. Representation of scale. The scale may be represented as a different ways. First of all, engineering scale. In these methods, scale may be represented by a statement. For example, 1 centimeter is equal to 10 meter. It means that 1 centimeter on paper represents 10 meter on a ground. Second one is representative fraction. In this case, the ratio of distance on the map to the distance on a ground is worked out in such a way that numerator is unity and denominator is a fraction in same unit of measurement as the numerator. Example of representative fraction. 1 centimeter is equal to 50 meter. In case of the representative fraction, it is equal to 1 centimeter divided by 50 meter, as 50 meter is converted into centimeter. So 1 meter is equal to 100 centimeters. So 50 into 100 centimeters. So representative fraction is equal to 1 divided by 5000. Both are in same unit. Now next one is graphical scale. The graphical scale is drawn on plan itself. A graphical scale is a line subdivided into plan distance corresponding to convenient unit of a length on a ground. Figure shows the graphical representation for an engineering scale of 1 centimeter is equal to 5 meter. So to prepare a graphical scale, draw a line of 12 cm long on a map. Divided it into 6 equal parts: 1, 2, 3, 4, 5 and 6. Each part will represent 2 into 5 is equal to 10 meter of a ground distance. Divide the first part into 10 equal subparts. Each subpart will be represent 1 meter of a ground distance. A distance of 36 meter can be represented as starting from 30 to 31, 32, 33, 34, 35 and 36. So the graphical representation of a scale on a map has the advantage that if the paper shrinks, the scale will also shrink accordingly and the distance representation will not be disturbed. Types of scale. First of all, plane scale. Plane scale is a one on which it is possible to measure two dimensions only. For example, meters and decimeters, hundreds and tenths, etc. Example of a plane scale. Construct a plane scale of 1 centimeter is equal to 3 meter and represent a 47 meter on it. Now, for these, draw a line of 20 centimeter long and divided it into 6 equal parts: 1, 2, 3, 4, 5 and 6 parts. Then this line will represent 20 into 3 is equal to 60 meters. So the total length, right, it is of 60 meter. Now each part will represent it as a 10 meter. Now the left hand side part is further subdivided into 10 equal parts. Each reading is of 1 meter. Now place 0 of the scale between the subdivided part and the undivided part. To take 47 meter, place one log of the divider at 40 meter and another at 7 meter. So the total distance will be 47 meter. Second type is diagonal scale. On a diagonal scale, it is possible to measure a three dimension such as meters, decimeters and centimeters, units, tenths and hundreds. A diagonal scale is made on a principle of similar triangles. For example, suppose it is required to divide a short distance PQ into 10 equal parts as shown in figure. For that, at a point Q, draw a line QR perpendicular to the PQ and then join a diagonal PR. Now, subdivide a QR line into 10 equal parts and draw a line parallel to the PQ so that this diagonal PR are also subdivided into 10 equal parts. Now, this subdivision 1 represent 1/10 of the PQ, 2 represent 2/10 of the PQ, 9 represent 9/10 of the PQ and so on. Example of a diagonal scale. Construct a diagonal scale of 1 centimeter is equal to 4 meters to read meters and decimeters and show on that a 36.5 meter. For that, draw a line of a 15 centimeter and divided it into a 6 equal part. For example, 1, 2, 3, 4, 5 and 6. Now, this line represents 15 multiplied by 4. It means total 60 meters. Subdivided the first left hand side part into 10 division. Right? From this to this, divided it into a 10 equal part. Each represent a 1 meter. At the end of the subdivision, erect a perpendicular line of any suitable length, for example 5 centimeter, and divided it into a 10 equal part: 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now draw a vertical line from 0, 10, 20, 30, 40 and 50 meter. Mark a 36.5 as a 30 to 0, it means 30 meter, and 36.5 for that 36 0 to 35 and 36 from these line, that is total 36, and for point 5, 0, point 1, point 2, point 3, point 4 and point 5. So this is equal to 36.5. A chord scale is used to measure an angle or set of angles. It is marked either on a rectangular protractor or an ordinary boxwood scale. Then vernier scale. As shown in figure, vernier scale was invented by Pierre Vernier to measure a fractional part of a smallest division of a graduated scale. Vernier scale consists of a main scale or a primary scale that is fixed and vernier scale that is movable on a primary scale. This is a jaws for measuring a inner dimension. If we have to measure a inner dimension of a hollow glass, then these inner jaws are used, and these jaws are used to measure a outer dimension. This is called as a stem. It is used to measure a depth. Direct vernier scale. In a direct vernier scale, the graduation in a main scale and a vernier scale increases in a same direction. The smallest division on a vernier scale is shorter than the smallest division on the main scale. It is so constructed that n divisions of the main scale are equal in length of n plus 1 division of the vernier. Let P that is equal to value of the smallest division of a primary scale and V that is the value of smallest division of a vernier scale. N is equal to number of division of the primary scale of a specific length. N plus 1 is equal to number of division of the vernier scale of a same length. So for determining the least count of the vernier scale, there is an equation that is equal to P, that is the value of smallest division of the primary scale, divided by the n plus 1, that is the number of division of the vernier scale of the same length. Thank you.